There are 3 tabs in the protein preparation wizard, which consists of all the tools for the stages for protein preparation. In the Import and Process tab, we can import a protein and perform basic tasks for fixing the structure. In the Review and Modify tab, we can delete unwanted chains and waters and fix or delete het groups. And in the Refine tab, we can optimize orientations of hydrogen bonded groups and minimize the structure. So for an unprocessed protein, such as one from the PDB, you should run through all 3 stages. Let's begin with an example. Here you can edit the job name if you wish, and note here the calculations will be performed on my local host, which has 4 processors. And throughout the process, we'll set it so we can see a mix of only polar hydrogens on the protein residues, but to also see all hydrogens for everything else, like het groups. Now for this example, we're going to use 3ERT, so here we're going to type 3ERT. But before we click Import, note that there are some options to include, such as including the diffraction data, which is useful for checking or refining the structure with prime X, for example, the biological unit. Here, all structures of the biological unit are merged into a single entry, and here you can also choose alternate positions if you want to make use of the alternate positions of atoms in the PDB file. Note, however, that these options are performed using the RCSB website, so internet access is required. Here, we won't use any of these options, so we'll just click Import. The PDB file is either downloaded automatically from the RCSB website, or it is retrieved from any local PDB installation if that has been set up. Note that we could have also browsed for the protein structure file. Once the structure has been imported, you will see it in the entry list and displayed in the workspace colored by the PDB conversion status. This scheme is a color-based error reporting scheme to call attention to parts of the molecule that may need additional attention. So in orange, we have non-standard residues, het groups for example. Red shows a standard residue but contains missing atoms. So if I right-click this residue and zoom in, you'll notice that it is a lysine, but with the side chain atoms missing. Missing atoms are often seen in regions of the protein that are highly mobile with high B factors. And we can quickly confirm this by changing the color scheme to Atom PDB Factor, and note that indeed these are regions of high B factors. Back to coloring by PDB conversion status, we also note some green residues. This shows a residue with an alternate conformation. So this histidine, for example, has an alternate conformation. Now we can either manually go into residue mode, select and right-click the residue and choose Switch Alternate Position, or because there may be several of these, we can use the Protein Preparation Wizard to handle them, which we'll do later on. Finally, grey atoms correspond to standard residues connected by standard templates, and that the confidence in bond orders assigned to these residues is high. Now here we have a collection of options to use when we pre-process. Align to gives you the option to align the protein to that of another protein that is either selected in the entry list or project table, or aligning to a PDB ID. The alignment is done with the Protein Structure Alignment tool in the Tools menu. This option will assign bond orders. This option will add missing hydrogens. You can also remove original hydrogens first, just to ensure that problems with hydrogen atom names or non-standard PDB atom names are fixed. Create zero-order bonds to metals. This option breaks bonds to metals, replacing them with zero-order bonds, and adjusts the formal charge on the metals and the neighboring atoms. Sulfurs that interact with metals have their hydrogens removed if necessary and are assigned a negative charge. This option will detect and add bonds between sulfur atoms that are within 3.2 angstroms of each other. Note that CYS cysteines will be renamed to CYX cysteines. This option will convert selenomethionines to methionines. Keep in mind that this option should be used if you plan on using the OPLS 2001 force field, while OPLS 2005 does have parameters for selenium. Fill in missing side chains using prime and fill in missing loops using prime are options to add and optimize these missing atoms by running a prime structure refinement job. Prime, of course, being the protein refinement application. Now, you can also do this later using prime separately, but since we know that we have missing side chain atoms in red, we'll click Fill in Missing Side Chains here. The Cap Termini options adds N-acyl and N-methyl amide groups to uncapped N and C termini. These termini include breaks in the chains where there may be missing residues. Now, if the residue breaks are far from the region of interest, such as a binding site, it may be sufficient to cap them. But if you prefer to fill in chain breaks rather than cap them, then you may want to select Fill in Missing Loops using Prime. Finally, this option deletes waters that are more than, in this case, 5 angstroms from het groups. So this is mainly useful for retaining waters that are important for ligand binding while deleting all other waters. Keep in mind though that there are other options for addressing waters in subsequent tabs. So for now, we'll just click Preprocess. And then we'll click Continue to confirm that we're running Prime as well in this example. Again, fill in missing side chain residues was an option, so if you're following along and don't have Prime, you can uncheck that option. So once that stage has completed, a new entry will be incorporated into the entry list and workspace. Note that the protein preparation problems dialog box opened, alerting us to potential problems with atom types, missing atoms, overlapping atoms, or alternate positions. Here, it's stating that we have a proline with missing backbone atoms. Now, Prime could only fix missing side chain atoms automatically, which is why it did not address the missing atoms on this residue. Now, we could either manually fix this, for example with the Maestro builder. However, because the region of interest for this specific protein is at the binding site and this proline is way out on the surface, far from the binding site, then it's safe to make a judgment call and ignore it for now. It looks like there are alternate positions reported for some residues. We already knew this as they were colored green when we imported the PDB, but here in the problems dialog box we can easily switch to their alternate position and see the current average occupancies as they change. By default, the position with the highest average occupancy is used, so here we'll just click OK. Note that in addition to the problems dialog box, we can also open the protein reports or Ramachandran plot at any stage during the process to monitor and inspect the changes we make. For example, here we can inspect the steric clashes.